All right, let's go ahead and graph using Mathematica. First, let's define two functions. The first function we're going to find is just the natural exponential. And we're also going to go ahead and define the log base 10. Okay, to graph a function in Mathematica, you have to use the plot function. So the plot function has two inputs. First, we input the function itself, let's say f of x, and then we're going to put in the domain of what we want to graph. Here we're saying graph all values of x between 0 and 10. Now, you can graph multiple functions using plot. And the way you do this is, again, we'll go ahead and input plot here. So we still have two inputs. The first input now is going to be a set of functions. Let's go ahead and plot f of x and g of x. And the second input is still going to be our domain. So again, let's look at this time all x values between negative, well, it has to be positive since we have a log. So between 0 and 5. Oops. So there was a small error. This should be brackets here. Let's go ahead and change that. So now let's go ahead and plot. Okay. So this is a little hard to see, but we have our blue function, which is our exponential, and we have our yellow function, which is our logarithmic equation. Let's go ahead and drop this log down, or actually, let's go ahead and look at another feature of a log, or the plot function. So we can go ahead and change the scale of what we're looking at. And the way we do that is, again, we take our function here. So we have two functions. We have the domain of our inputs. And now what we want to go ahead and do is we want to go ahead and look at a y value range. So we're going to change the scale of our y values to be all y values between -10 and let's just say 50. Oh, so here there's a little error because we forgot one thing here. Whenever you use plot range, you have to make sure to plug in an arrow here. Now let's go ahead and plot. All right, so we can see a little bit more of what's going on here. We can see again that our logarithm function is moving very slowly. It's growing very slow, whereas our exponential is growing very fast. So let's go ahead and try and limit the range of our y values even more so that we can see the difference between these two functions. All right, take another copy of this. Paste. Now let's have the upper bound of our y's be 10. Okay, so now we can clearly see that our logarithm in comparison to our exponential is growing incredibly slowly. So I think that is what all we're going to look at in this video. Actually, let's go ahead and show one more thing. So another thing that you can do with the plot function is you can go ahead and add transformations to when you're plotting your functions here. So for example, let me go ahead and get rid of our y values here. Actually, let's change this to a 10. And now what we want to do is let's go ahead and look at plotting our logarithm. So we're going to plot our logarithm g of x, and let's apply a transformation to it. The transformation that we're going to apply is, let's say, +7. And we can go ahead and flip this upside down. So this should go ahead and plot both our logarithm and the transformation of our logarithm. There we go. In this graph over here, the blue function is our logarithm, and the yellow function is our logarithm after we applied our transformations. All right, so let's stop here.